This is Britt Caswell with a video explanation for the examples in the SavvasRealize textbook. This is section 1.1, example 1. This entire example is all about understanding what a domain and a range are. So the first thing I'm going to do is actually define those terms. So a domain is all of the potential inputs to a function. So it's every x value that could be plugged into a function in order to try to solve. A range then is all of the potential outputs. So if I plug in a number, the range is all the numbers that would come out from there. Okay, so the domain is tied to the x values, and then the range is tied to the y values. So this first question, part A, it's asking what is the domain and range of the function that is defined here. And what I've done is I've gone ahead and I've graphed this quadratic function. Now there's two types of notation that we're going to talk about, okay? I'll be teaching it with set builder notation but also interval notation, because you will see both of those as you guys move through mathematics. But before we get into all the notation about it, let's just look at what values can be plugged into the function, okay? So let's start with the x values. So in terms of the x values, I can really plug in any number here, right? I could plug in a -64. I could plug in a 2. I could plug in 0. There's nothing that I can't square and subtract 3 from that would cause an issue within a function like this. Okay, you could see it here on the graph because this parabola, it continues, right? So if I change to like a reddish color, you see this arrow is continuing kind of this way, okay? It continues going up and out. So along the x-axis, it's going to continue towards positive infinity for forever. The same thing here, right? This one continues to go up and out. So in terms of just the x-axis, it's going that way towards negative infinity for forever. Okay? So I'm going to say that one goes to negative infinity, that one goes to positive infinity. Some people like to put a little plus next to their infinity sign. So in terms of the x values, okay, it covers all real numbers. Okay, that's what that funny sign means, is all real numbers. People like to use that when we're too lazy to write all real numbers, just like I was too lazy to write the number word there. So now let's talk about the range. Okay, now the range talks about the y values. So we are looking at what the potential outputs were from this function. Now these arrows that I had drawn, right, they're still going up for forever and forever and forever. You see it here in the green, it's still going upwards for forever. The same thing on this other side. So we know that this function goes towards positive infinity on our y-axis, because it goes up for forever. However, look at the shape of this function. It's a U. So if we have a U shape, also called a parabola in mathematics, there has to be a bottom of it. So right now, the y-axis is going down here to -3. See, it's not going lower. There's not a -4 for the y values on this graph. So that means that we are looking at the values. The lowest value is -3, and then the highest value is at positive infinity. So now we know kind of our number restrictions, and we have to look at the notation that we want to describe it as. So let's start with the set builder notation. So to describe this set builder notation, I'm going to say that the domain, okay, using a capital D, is equal to, and then we use these little curly brackets, the ones that look like that. So we're saying the domain is equal to all of the x values where x is a real number. And then we close that curly bracket. So this vertical bar here, that is just the word where. So I'm going to read that again just a little quicker. The domain is all of the x values where x is a real number. Now if there's a restriction there, right, if it's all real numbers except for like 7 or something like that, you could say x is a real number and then comma x equals not 7 or something like that. Okay, so this one reads very directly like a sentence, and so that's kind of nice with this notation. So now let's look at my range. So our range, remember we were talking about how it's talking about y values. So I would say my range, there's my set, is equal to, we start the set, our range is equal to a y value, where, now this one I'm actually going to use to describe an inequality, okay? If I had tried to talk about the real number for x as an inequality, it's kind of messy. But in this case, because there's kind of a lower bound and then it goes on to infinity, that works really nicely to have some kind of inequality. So I'm going to say here that y is greater than or equal to -3. And then I'm going to close that boundary. Alright, because if we think about just what's happening on this y-axis, its minimum value is -3, and then it can go on up towards positive infinity. So that's how we show it in set builder notation. So now let's look at interval notation, which is my favorite when I'm talking about these domain and range values, because it's short and sweet. It works just like an ordered pair, okay? Now understand, when we do interval notation, we start from the negative side to the positive inside. So when we're talking about x being real numbers, I'm going to be looking on the x-axis the most negative value it can be, and then I'm going to put the most positive value that it could be. So in this case, my interval for my x values for my domain is from -infinity to positive infinity. Okay. Now we have to choose some brackets. Okay. Now there's two types of brackets. So if you have square bracket, the number is contained. It means it can equal that value. If you have a round bracket, the number is not contained. I think of this as equivocal to when we use inequalities, having that bar or not, okay? So if there's a square bracket, it can be equal to, like in this inequality. If there is a round bracket, it cannot be equal to. So in terms of our domain, you can never actually reach an infinity. So my brackets on here are going to both be the not contained, because you can never reach the actual infinity. So now when I go to talk about the range, my smallest value is at -3, and that y value can equal -3, so I'm going to use a square bracket next to the -3, because I know that this parabola is going to touch down right there. And then this goes up and up and up for forever, so it goes towards positive infinity. And again, because you can't reach infinity, they're going to use a curved bracket there. So this one ends up looking kind of like a bullet. Alright, let's do another part of this example. So we have an air tanker. It's right there. It's going over forest fires, and it drops water at this constant rate until its tank is empty. And so what they're wondering is what is the domain and range of the function that represents the volume of the water the air tanker can drop in X seconds. So let's talk about what this is actually saying. Okay, it's giving us two types of values. The first is the volume, and that volume is happening, like it's changing, in respect to X amount of time. So in terms of a graph, for example, that means that my volume is going to be on the y-axis because it depends on the amount of time that's passing. So that's where my x is time. So then we have to think about kind of how this looks. Okay, so at 0 seconds, okay, that's on the v-axis here. At 0 seconds, we have to think about the maximum amount of water that's in this air tanker. It says it here in this bubble. It says the maximum amount that it's going to have is 8,000 gallons. Now, somewhere along this axis, along the x-axis, we know that there's going to be 0. Like, we know that eventually it runs out of water. So what we have to actually do is we have to think about this part here. Now, the problem said that it's releasing at a constant rate. Okay, so that means every single second this water is being released at 400 gallons at a time. So what we need to do is figure out how many seconds pass for this volume to be 0. So what I would recommend doing here is taking the 8,000 and dividing it by 400 in order to see the number of seconds, and that's going to be 20 seconds. So right here, when x is 20, our v value is 0. So here is our line. Okay, the ordered pairs here are 0, 8,000, and 20, 0. So now let's talk about our domain and our range. So the domain is all of the x values that are contained. Okay, I'm going to choose to do my domain here in set builder first. Okay, you usually would pick one or the other. I just want to show you both for an example. So if I'm doing set builder notation, I'm going to put SB here. My domain is the set of x values where, and then we're going to probably think about some kind of inequality here, right? Because there's a minimum x value and there's a maximum x value. It doesn't contain all real numbers, so we need some kind of inequality to help us out. So my minimum x value is right here at 0 seconds. So I know that x is between 0 and then the biggest value here is 20. So I know that I'm going to have some kind of compound inequality like this. And I know x is greater than the 0, and I know that x is less than 20. So there is my set builder notation. Now for my range, I'm going to say the range is equal to, and remember range talks about all the y values, and my inequality is going to look the same way. It's going to be y being sandwiched between two values. In this case, my smallest y value, okay, so the smallest part on this axis that the graph is passing, is at 0. And then the largest y value is 8,000, I'm sorry. Some people are tempted, they'll flip around the 0 and the 8,000 here. because they tend to go from left to right. Just remember the y-axis, or our range axis, is going to be talking about from the bottom to the top. Alright, so now let's show this again, but let's do it with interval notation. I'm going to call that IN. So my domain here contains these x values, right? So I can have 0 seconds, and I can have 20 seconds, okay? So I'm going to use those square brackets to kind of contain that time frame. My smallest x value we said was at 0. My largest x value we said was at 20, and there's that notation. My range then, again, is going to be bricked up, right? Because I can have maximum tank capacity, or I could have 0 tank capacity, right? And we said that our range goes from 0 to 8,000. So it's a little cleaner in that interval notation. So then we get to this try it. Alright, so for this try it, what I recommend doing is actually graphing these functions. Did I put graphs? I didn't put graphs, so we're going to graph them. So I'm going to give you guys a little bit of a plug here. Desmos.com is your BFF right now, especially while we're here in quarantine. So Desmos.com has a free graphing calculator on it, which you can also download as an app on your phone. So I recommend making sure that you have that, because it's going to really make your life easier. Plug over. Alrighty, so y equals the absolute value of x minus 4. So if you remember your transformations from Algebra 1, this minus 4 is within the grouping symbol. So it is going to be moving my absolute value to the right by 4. Alright, so to the right by 4. Now the absolute value is actually like a V shape. Okay, so I know that my absolute value is going to go kind of up 1 over 1, up 1 over 1. And then it mirrors across this way. So I can back 1 over 1, back 1 over 1, back 1 over 1, and there. So that's my rough graph of it. Alrighty. So set builder notation. Let's identify our x values. So if I'm looking at this x-axis, this graph is continuing backwards on the x-axis all the way here to negative infinity. It goes for forever to the left. When I look to the right, it's going all the way over here to positive infinity. So my domain is equal to all the values of x that go from negative infinity to positive infinity. Okay, you could write it like this. Oh, you can't equal infinity. Don't use the bar if you do this. Go away, little bar. There we go. So you could say negative infinity is less than x is less than infinity. That's fine as well. Or another way to write that is you could say all real numbers. Okay. For our range value, now we're going to be looking at the y values, right? So we're looking at the range is equal to the set of numbers where for y values, where, and we need to look at our minimum and maximum y values. Absolute value functions, they go up for forever. So on the y-axis it goes to positive infinity. But our smallest y value, the graph actually cuts off here at 0. So for my inequality, I'm going to say y is greater than or equal to, it's equal to because it's on the bar, 0, because that's our minimum value. Then we close that curly bracket. Be careful if you're writing these notes by hand that your curly brackets don't look like 3s, because I often get a little bit of in a rush and I'll make those look like 3s on accident. So watch yourself if you're sloppy-handed like I am. Alrighty, so now let's do that interval notation. It is way quicker. So my domain here, we know it's in negative infinity to positive infinity. Remember, when you're using infinity, to use the curved brackets. My range, okay, we said goes from 0 to infinity. And then we look at if it's included or not. This does touch at 0 right here. So I'm going to use the square bracket at 0 and the curved bracket at infinity because you can never reach infinity. So now what I would like you guys to do is I would like you guys just to take a second, take a deep breath, and try to remember a little bit about graphing because this is where people are going to struggle the most, I anticipate, is remembering kind of the shapes of some of these graphs. Alrighty, so our next graph, this one is going to be a quadratic. What that means is it's going to have a parabola because there's a square as my highest exponent. Don't let the complexity of the equation throw you off, okay? Just plug it into your Desmos calculator. So when I'm plugging mine into my Desmos app, I'm getting a graph that looks like this. Alright, there's a parabola, it's kind of going through 0, 0, goes up, comes down like this. So some of our kind of key points here, okay, that here is at 3. Okay, our maximum is at about 1.5. Oh, I need to move that line over then. It's at about 1.5 and then 4.5. I'm going to label that ordered pair, but just understand where it's coming from. Desmos is really nice because it gives you these points you could just click instead of having to remember how to graph by hand. Okay, I think that's all the points that we really need. I mean, you can put in your little tick marks if it makes you happy. But that's not really focused on, right? We're focused on domain and range here, not necessarily graphing it beautifully. So let's start with the set builder notation. Okay, we're going to be looking at the domain, which is the x values. So our domain is equal to the set of all x's, where, and we need to look at our x's. So do you see how this parabola is continuing down and to the left for forever? And that means I'm going to look at negative infinity on the x-axis. And then the parabola is mirrored, right? Those are symmetric graphs. So if it's going for forever to negative infinity, it's also going to go forever on the x-axis towards positive infinity. So that means that x is a real number. Here's another way to write that if you don't want to write all the words out. So now let's look at our range. So our range is equal to the set of y values. And then we have to actually look at what y values are being covered. These arrows at these end points here, they're going down for forever, right? So we know that y is going towards negative infinity. But our biggest y value is here at 4.5. So that means we're considering all the y values that are less than or equal to 4.5. And that's where that comes from. And then we close our curly bracket. Alrighty, so now the interval notation, that nice short and sweet notation. So my domain for this one, we said goes from negative infinity to positive infinity. And remember, when you use an infinity with this notation, to use the curved bracket. And then for our range, Remember, you have to start bottoms to the tops. So the bottom value here is negative infinity. Top value here is 4.5. You can't ever equal the negative infinity, but you sure as heck can fit that 4.5 in there. So make sure to use the square bracket on that 4.5. Alrighty, so it was kind of long, but that was our example 1 from section 1.1. Until next time.